Welcome back to the deep dive. Today we are pulling a document off the stack that, I gotta be honest, looks like the absolute cure for insomnia.
Yeah.
It's called E2.3 Employer Requirement Engineering. It's dense, it's bureaucratic, and it's just, filled with acronyms.
It's not a beach read, that's for sure.
But, and you have to stick with me here, this is actually one of the most revealing texts we've looked at in a long, long time.
You're right. If you can kind of strip away the dry language, you're not just looking at a rule book. You're looking at the immune system of a mega project.
That is a great way to frame it.
Yeah.
If you've ever looked at a massive oil refinery or a huge bridge and just wondered, how on earth did 10,000 people build this without it just collapsing into chaos?
This document is the answer.
This is it. We're analyzing revision '01 of these engineering requirements. It's basically the Constitution an employer hands to a contractor. It says, look, if you want to design this thing for us, this is the rigid framework you have to operate in.
And our mission for this deep dive is really to look past the technical specs. We're not talking about, concrete grades or steel strength.
Right.
We're focusing on the process. How is design and engineering managed in these really high-stakes environments?
Yeah.
And we're going to see that quality isn't just about being a good engineer. It's about submitting to this rigorous, almost painfully detailed bureaucracy.
A bureaucracy designed to catch mistakes before they happen.
Exactly.
So we'll be pulling from the text, and we're also going to break down this really telling diagram that's in the source about engineering office alignment.
Which is a lot more complex than it sounds.
Oh, much more. So let's get into it. The document opens with a requirement for something called the engineering plan.
Right, section 2.1.1.
Now, for anyone new to this, you might assume that's the blueprints.
No, not at all.
It's described as part of the PEP, the Project Execution Plan.
It's meta-planning. It's the plan for the plan. Before the contractor can draw a single line, they have to submit a document that details how they're going to do the engineering.
And the employer isn't looking for, a short paragraph saying, we've got a great team.
No, no.
The granularity here is just aggressive. The source text lists, 20 specific items that have to be in this plan?
At least.
They need org charts, sure, but they also want specific agency staff ratios. That one jumped out at me. Why is the employer micromanaging the ratio of freelancers to staff?
It's all about institutional memory and risk. If your agency ratio is, say, 80%, that means most of your workforce is temporary.
Right. They could be gone in 3 months.
Exactly. And in a project that spans 3 or 4 years, if those people walk out the door, the knowledge of why certain decisions were made walks out with them.
So the employer wants to see stability.
They want to know that the brain trust isn't going to just evaporate halfway through.
You're protecting the project's IQ.
That's a really good way to put it.
Yeah.
You're buying the brain power, not just the drawing itself.
They also have to list every specific engineering center. So you can't just farm work out to a satellite office without declaring it.
You can't. And then there's the handling of free issue items.
What does that mean exactly?
That's equipment provided by the employer or, a third party, like an OEM, an original equipment manufacturer.
Okay.
So say you're building a plant and the employer has already bought a massive gas turbine from Siemens. They give it to you and say, integrate this. That's a free issue item.
And the contractor is responsible for making it fit.
Even though they didn't buy it. The plan has to show exactly how they'll handle that data, because if that turbine doesn't fit the foundation, well, the contractor's going to have a very bad day.
Which brings us to this very corporate-sounding phrase, interface management.
Ah, yes. Interface management is where projects live or die.
Really?
In any complex build, you have the electrical team, the structural team, the piping team, all working in parallel. Interface management is the discipline of managing the collisions between them.
The classic pipe hitting the beam scenario.
That's the one. Or a cable tray running right through a space you need for an HVAC duct. This requirement says, tell us your system for spotting these clashes before we pour the concrete.
So the left hand knows what the right hand is doing.
Or, more importantly, what it's about to build.
And that's closely related to the management of change process. I imagine you can't just erase a line because you had a better idea over lunch.
Absolutely not. If an engineer decides to change a pipe from, say, 4 inches to 6 inches, that triggers a butterfly effect.
Oh, of course.
The pump size might change, the power draw goes up, the electrical panel needs an upgrade, the structural support needs to be heavier.
So management of change is a formal procedure to track all those ripples.
You have to prove you've analyzed the impact on cost, on schedule, on safety before you make that tweak. It stops scope creep.
Let's talk about the timeline. Because Section 2.1.2, Design and Engineering Planning, really lays down the law.
This is where the commercial side meets the engineering side. The text explicitly says the schedule has to account for at least 2 review cycles by the engineer.
So I submit, you critique it, I fix it, I submit it again. Why 2?
Because the first one is almost never perfect, it's just a reality check. The employer assumes you'll get things wrong the first time.
But there's a clause in here with some serious teeth.
Oh yeah, the weaponized clause. It says, review delays caused by contractors' non-compliance will be for the risk and account of the contractor.
For the risk and account of. That sounds like legal speak for you are paying for it.
That's exactly what it is. It means if you submit a sloppy drawing and that rejection pushes the schedule back 3 weeks, you don't get an extension. You eat that cost.
Wow, that completely shifts the incentive.
It monetizes quality. Poor quality becomes an immediate financial liability. It stops the contractor from using the employer's review team as, their own QA department.
And these reviews are not casual chats. Section 2.1.3 talks about design reviews as these formal ceremonies. It even mandates safety rituals, AGO and HAZID.
Those are the heavy hitters. AGOP is hazard and operability analysis. HAZID is hazard identification.
What are those really?
They are forensic interrogations of the design. A whole team sits in a room and goes through the diagrams, the P and IDs, line by line, valve by valve.
That sounds incredibly tedious.
It is, but it's life-saving. They ask questions like, what happens if this valve sticks open? What if pressure spikes here? If you miss one of those scenarios in that room, it could mean an explosion 3 years down the line.
And you can't just spring these meetings on the employer.
Nope. The 21-day rule. The engineer needs an invitation and all the documents 21 days in advance.
3 weeks prep time for a meeting.
It just emphasizes the depth required. You can't cram for this stuff. It forces this slow, deliberate pace. It prevents the rush to failure.
Okay, so we have the plan, the schedule, the reviews. Let's talk about the brain of the whole operation. Section 3 introduces the MDR, the Master Document Register.
If the engineering plan is the Constitution, the MDR is the census. It has to reflect the actual status of each individual contractor document.
And when they say each, they mean everything.
Every drawing, every calculation sheet, every report. In a major project, that could be tens of thousands of unique documents.
It's a living database.
And if it's out of sync with reality, the project is flying blind. You might build something off an old version of a drawing, which is the cardinal sin of construction.
And that brings us to file formats. Section 2.3. This was interesting. It demands native format alongside the PDFs.
That is a crucial point. If you just send me a PDF of a calculation, I can see the result. I can see you claim the beam holds the weight.
But you can't check the work.
Exactly. But if you send me the Excel sheet, the native format, I can click the cell and see the formula. I can see if you divide by the wrong number. I can check your math.
It's all about auditability.
Completely. And they even list specific tools. Primavera P6 for planning, MS Excel for registers, MS Word for meeting minutes. They want the raw data.
I want to pull up that visual we have. The diagram labeled Engineering Office Alignment. It really helps visualize how all this data moves.
This diagram is basically the blueprint for how you coordinate a global workforce without losing control.
So describe it for us. At the bottom, you have 2 little buildings drawn. Main engineering office and other engineering offices.
Which right away implies a distributed team. Maybe the high-level design is in Houston, but the detailed drafting is in Mumbai. That's pretty standard.
And connecting them is an arrow-labeled contract. But flowing above them are 2 clouds. One is employer EDMS, and one is contractor EDMS.
EDMS is the Electronic Document Management System. Think of it as a super secure vault for files that tracks every single version.
And the arrows show documents flowing from the offices into the contractor's cloud, and then, and this is the key, mirroring up to the employer's cloud.
That mirroring is vital. The employer wants their system to reflect the contractor's system in near real time. It allows for continuous oversight.
So if a drawing gets uploaded in Mumbai,
Yeah.
someone in London can see it immediately.
That's the idea. And Section 2.3D adds a legal layer to all this. Digital signatures.
Right, by means of proven software. It even mentions Adobe.
The key part is that it has to comply with the signature standards in the country. This isn't just pasting a picture of your signature, it's a cryptographic key. It proves who signed it and when. If a structure fails 10 years from now, they need to be able to trace that specific beam calculation back to the specific engineer who signed it. It's about accountability that holds up in court.
Speaking of accountability, let's talk about the people. Section 2.1.7, continuity of technical personnel. This felt like a clause designed to prevent dump and run.
That is exactly what it is. There's a temptation for design firms to finish the drawings, collect their fee, and move the A-team to the next big project.
Leaving a skeleton crew.
Right. This clause says no. The key designers have to be kept closely involved until the design is verified by testing and commissioning.
You have to stay until the lights turn on.
And it changes how you design. If you know you're going to be standing there in the field when they flip the switch, you're a lot more careful about your work.
Then there's section 2.1.13, which I'm calling the roommate rule. The contractor has to provide office space for the employer's people right in their main office.
Heh, yeah. The employer wants to move in. It's standard practice, but it can be a little awkward.
Is it really just surveillance, like a teacher watching you take a test?
It's partly that, sure, but it's mostly about latency, about speed.
How so?
If I'm the employer and I see a problem, I don't want to write a formal letter. I want to walk 10 feet to your desk, point at your screen, and say, let's fix this now. It solves problems while they're small.
But with multiple offices, like the diagram showed, you have a coordination issue.
And Section 6 addresses that. If the contractor splits the work across locations, they have to run a formal engineering onboarding program.
And it's not just, here's a coffee machine.
Oh, no. They have to teach the specific scope of work, the contract summary, all of these requirements, and this is the real clincher, they have to keep an onboarding register.
A list of names.
If your name isn't on the list, you haven't been trained. If you haven't been trained, you shouldn't be touching the drawings. It fights entropy.
It's incredible how much paperwork is generated just to prove you read the paperwork.
That is the cost of assurance.
So what are we actually making? Section 7 gives us a list of design and engineering deliverables, and it is just a massive laundry list.
And it says this is just a typical list. It's not even exhaustive. It's just there to set the scale.
I pulled out a few just to show the variety. You have the standard 3D model.
Sure, and plot plan.
But then you get into the real weeds. Fabrication isometrics with bill of materials.
Yep. That is a unique drawing for every single pipe spool. It tells the fabricator exactly where to bend it, how many bolts to use. There are thousands of those.
Then firewater plan, new soil study, demolition drawings.
Demolition is a huge one. Sometimes you have to surgically remove old stuff before you can build the new stuff. That takes as much engineering as building it.
And electrical heat tracing. What is that?
Keeping the pipes warm. If you have fluid in a cold place, it can freeze or get thick like molasses. Heat tracing is basically wrapping the pipes in electric blankets.
It really drives home that this isn't a static building. It's a living machine.
And all those systems have to work together. That's why the list is so long. It covers every single part of that organism.
To track all this, the document wants reports.
Yeah.
But it makes a distinction between weekly and monthly reports.
A very distinct difference in altitude. The weekly report is tactical. It's for firefighting.
Key issues and areas of concern.
Right. We're waiting on this permit. This vendor is late. It's the action log.
Versus the monthly report.
That one's strategic. It asks for the updated plan showing progress and float.
Explain float for us.
Float is your buffer. It's the amount of time you can delay a task without delaying the whole project. The monthly report forces the contractor to answer, do we still have a safety margin?
And it requires corrective actions. You can't just report bad news.
You have to report the solution. We're late, and here's our plan to catch up. It forces them to be proactive.
So when you step back and look at E2.3 as a whole, this dense, boring document,
Yeah.
what is it really doing? It feels like it's trying to turn a chaotic human process into a machine.
It's mechanizing trust. That's the core of it. In a small project, you trust the craftsmen because you know them.
Right.
In a billion-dollar project with thousands of strangers across 3 continents, you can't rely on a handshake. This document replaces the handshake with a system. It forces the contractor to prove they're organized every single day.
That sounds stifling.
It is stifling. Engineers often hate it. But the alternative is, well, it's disaster. Without the MDR, you build the wrong version. Without interface management, the pipe hits the beam.
These boring rules are the load-bearing walls of the project.
That's a great way to put it.
Mechanizing trust. I like that. Before we go, there's one last detail I want to leave the listener with. In the deliverables list, there's something called the Technical Deviation Register.
Ah, yes. The official list of broken rules.
Exactly. If the engineering plan is the law, this register is the list of all the laws the contractor broke with permission. They asked, can we do this a different way? And the employer said, okay, just this once.
Right, approved exemptions. Maybe a certain material wasn't available or something.
So here's the thought I want to end on. In a massive project that runs for years, that technical deviation register, it grows. It starts empty, but line by line, it fills up. At what point does the list of exceptions become longer than the list of rules? And if you have enough deviations, is the thing you finally build actually the thing you designed in the first place?
That's the ship of Theseus paradox, but for engineering. If you change enough requirements, do you still have the same project?
Something to chew on the next time you look at a skyline. Is it the building they drew, or is it the sum of all the compromises they made along the way? That's all for this deep dive into engineering requirements. Stay curious.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.